Hello, in this lecture we will find the area of the yellow circle. We have in the picture semicircle, and the center of the semicircle is at point O, and inside the semicircle we have the yellow circle, and the touching point between the yellow circle to the semicircle is at point P, or the point of contact between the yellow circle to the semicircle is at point P, and the size of the line segment PQ equals to 7 times root 2. Actually, in order to find the area of the yellow circle, the only thing that we have to do is to find out the radius of the yellow circle, because actually the radius of any circle is equals to I mark area as A, equals to pi times the radius square, pi times r, that is abbreviation for radius square. Okay? So that is the area of any circle. So after we know the radius of the circle, the yellow circle, we will know the area, because we will multiply the radius, we will square the radius, and then we will multiply it by pi, and that will be the area of the yellow circle. Okay? So we will define the center of the yellow circle as M, and then we will connect points O and M together. Actually, the line segment OM equals to the radius of the yellow circle, because the line segment OM starts from point M, that is the center of the semicircle, and ends at point O, that is a point on the yellow circle itself. And that is exactly the definition of a radius. At any circle, the radius of that circle will be equal to the is defined as line segment that starts from the center of the circle and ends at any point on the circle itself. So according to this definition, MO is the radius of the semicircle, and actually we have a rule. I will call it rule number 1. Rule number 1 states that if two circles touch each other, either internally or externally, Then their point of contact lies on the straight line joining their centers. I will read again rule number 1. So rule number 1 states that if two circles touch each other, either internally or externally, then their point of contact lies on the straight line joining their centers. Now I will explain rule number 1. In the picture we have the yellow circle and the semicircle, and actually they touch each other at point P, or the point of contact between them is at point P, or point P is the touching point between the yellow circle to the semicircle. So rule number 1 states that the point of contact, that is to say point P, lies on the straight line joining their centers. So rule number 1 states that the point of contact, that is to say point P, lies on the straight line. Point P lies on a straight line. Which straight line? The straight line that joins the centers together. We have two centers. Point M is the center of the yellow circle, and point O is the center of the semicircle. And the segment line MO connects the two centers together. And rule number 1 states that point P is on the same straight line as MO, that is to say PMO is a straight line. Okay? Again, the point of contact, that is to say point P, lies on the straight line. Which straight line? Point P lies on straight line. Which straight line point P lies? Point P lies on the straight line that joins the centers together. That is to say MO joins segment line MO joins the two centers together, and point P lies on that straight line. That is to say PMO is a straight line. Okay, I will explain again. If two circles touch each other internally or externally, then their point of contact, that is to say point P, lies on the straight line. Point P lies on straight line. Which straight line? The straight line that joins their centers together, and the line segment MO joins the centers together, and point P lies on that straight line. That is to say, PMO is one straight line. Okay? Because point P lies on the straight line that joins the centers together. MO is the line segment that joins the two centers together, and point P lies on that straight line segment. That is to say, PMO is a straight line. Okay? Again, the point of contact, that is to say point P, lies on the straight line joining their centers. The straight line that joins the centers together, that is to say MO, point P lies on that straight line. That is to say PMO is a straight line. Okay? So we have two centers of those two circles. Center M, point M is the center of the yellow circle, and point O is the center of the semicircle. And the segment line that joins the two centers together is MO. And rule number 1 states that point P lies on that straight line. That is to say, PMO is straight line, because point P also lies on the segment line that joins the two centers together. It lies on the same straight line of MO. That is to say, PMO is one straight line. Okay? Or we can also say that PO is a straight line. So I'll explain it the last time. If two circles touch each other internally or externally, then their point of contact, that is to say point P, lies on the straight line joining their centers. The point of contact P lies on straight line that joins the centers together. That is to say, MO, line segment MO, that joins the two centers together, point P lies on that straight line. That is to say, PMO is one straight line. Okay, or we can also say that PO is a straight line. Okay, so we can also say that MP is the center, is the radius of the yellow circle, as well as MO, that is the radius of the yellow circle. So PO or OP actually equals to 2 times R, as you can see from the picture. PO equals to 2 times R, that is actually the diameter of the yellow circle. Diameter of the yellow circle. Okay, PO equals to 2R, and PO actually is the diameter of the yellow circle. And because of the fact that PO is a straight line, we can say that OP is the radius of the semicircle. So I will mark it as capital R. OP is the radius of the semicircle. Because OP is the line segment that starts from the center of the semicircle and ends at point P, that is a point on the semicircle itself. For that reason, it is defined as the radius of the semicircle. So from one side, OP equals to the radius of the semicircle, and from the other side, OP equals to 2 times the radius of the yellow circle. Okay? From one side, OP equals to the radius of the semicircle, and from the other side, OP also it is the diameter of the yellow circle, or it equals to 2 times the radius of the yellow circle. And from those two equalities we can deduce that capital R equals to 2 times small r. Okay, and that will be our first equation. Capital R equals 2 times small r. Okay, it is very simple. OP equals to capital R, OP equals to 2 times r. From that we can deduce that capital R, the radius of the semicircle, equals to 2 times the radius of the yellow circle. Okay? And actually OQ is also the radius of the semicircle, for the same reason, because it starts from the center of the semicircle and ends at point Q, that is a point on the semicircle itself. For that reason, OQ is the radius of the semicircle. And actually we have also rule number 2, and rule number 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. I will read again rule number 2. Rule number 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and we have a tangent to that radius, let's call it T, then the radius is perpendicular to the tangent, that is to say this angle is 90 degrees and also this angle is 90 degrees. Okay, so in any circle a radius and the tangent to that radius are perpendicular to each other. Okay, actually we can implement rule number 2 in our circles because we have a line segment MO, that is the radius of the yellow circle. The radius of the yellow circle is we have the radius MO, and we also have OQ, that is the tangent to that radius. So according to rule number 2, they are perpendicular to each other, or the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees, or angle POQ is 90 degrees, and also angle POL is 90 degrees. Okay? Again, because of the fact that we have a radius, MO is the radius, and QO is the tangent to that radius, so they are perpendicular to each other. So the radius is perpendicular to the tangent, to its tangent. That is to say, for that reason, according to rule number 2, angle POQ will be equal to 90 degrees because the radius is perpendicular to the tangent, that is OQ. So angle POQ will be equal to 90 degrees. Okay, so we actually can draw again the right triangle POQ. As you can see, side PO of right triangle POQ equals to R, and also side OQ of the right triangle equals to R, and the hypotenuse of right triangle POQ equals to 7 times root 2. Okay? So this is the right triangle POQ. Side OP of this right triangle is capital R. Side OQ is also capital R, and the hypotenuse of this right triangle equals to 7 times root 2. So we can implement here the Pythagorean theorem in order to find out the value of capital R. Actually, the Pythagorean theorem states first of all, it applies only on right triangles. So I will start the theorem by saying that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read it again. The Pythagorean theorem. So the Pythagorean theorem states that in a right triangle it applies only on right triangles. So it states that in a right triangle the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so I will explain the Pythagorean theorem. So in this right triangle, the square of the hypotenuse, that is to say AC square, equals to the sum of the squares of the perpendiculars. That is to say AC square equals to AB square plus BC square. Okay, the square of the hypotenuse, that is to say AC square, equals to the sum of the squares of the perpendiculars. That is to say AB square plus BC square. Okay, AC square equals to AB square plus BC square. Very simple. So we can implement this rule in our triangle. And as you can see here, the square of the hypotenuse, that is to say PQ square, equals to the sum of the squares of the perpendiculars. That is to say, PO squared plus OQ squared. Okay? PQ squared equals to PO squared plus OQ squared. But we know that PQ equals to 7 times root 2, PO equals to capital R, and OQ equals to R. So we can put the data in the equation and we will find the value of capital R. So instead of PQ, we can substitute PQ by 7 times root 2 because PQ equals to 7 times root 2. Can substitute PO by R because PO equals to R. You can substitute OQ by capital R because OQ equals to capital R. So in total we got that 7 times root 2 square equals to R square plus R square. 7 times root 2 square equals to 7 squared, that is 49, times root 2 square is 2. So in total we have 7 times 2 equals to R square plus R square, and R square plus R square equals to 2 times R square. Okay, so here we got 49 times 2 equals to 2 times R square. We can divide the equation by 2. We will get that 49 equals to R square. So after we divided the equation by 2, we got that 49 equals to R square. Now we will take out root. We'll take a root out of the equation, and then we will get that 7 equals to R. So after we took out a root of that equation, we got that the root of 49 equals to 7, and the root of R square equals to R. Actually, the root of 49, it can be also negative 7, but because of the fact that we are dealing with radiuses, it cannot be a negative. Radiuses can never be negative numbers, so we will take into account only the positive root of 49, and that is actually 7. So the radius of the semicircle equals to 7 units, but that is actually equation number 2, but from equation number 1 we know that capital R equals to 2 times small r. According to equation number 1, capital R equals to 2 times small r. So we actually can substitute capital R by 7 because capital R equals to 7. We will get that so we substituted capital R by 7. We got that 7 equals to 2 times small r. We will divide the equation by 2. We will get that small r equals to 3.5 units. Okay, we got that small r equals to 3.5 units, and now we actually know that the area of a circle that is A equals to pi times r square So we know that the area of a circle equals to pi times r square, pi times the radius square. But we know also that the radius equal to the radius of the yellow circle equals to 3.5 units. So we can substitute r in the formula of the area of the circle by 3.5 units. Okay, so we'll get that the area of the yellow circle equals to pi times 3.5 square. Okay, we substituted r by 3.5. We got the area. We got that the area of the yellow circle equals to pi times 3.5 square. The square of 3.5 is 12.25. So the area of the yellow circle will be equal to 12.25 times pi. Okay, 3.5 squared equals to 12.25 times pi, and pi times 12.25 equals to the area of the yellow circle. So the area of the yellow circle will be equal to 38.48 units. So the area of the yellow circle equals to 38.48 units, because pi times 12.25 equals to 38.48 units. So the area of the yellow circle equals to 38.48 units. Okay, so now I will summarize the lecture. Actually, we wanted to find the area of the yellow circle, and we have in the drawing a semicircle. The center of the semicircle is at point O, and inside the semicircle we have the yellow circle, and segment line segment PQ equals to 7 times root 2, and the touching point between the semicircle and the yellow circle is at point P. Point P is the point of contact between the yellow circle and the semicircle. Actually, we also know that the center of the semicircle, that is to say point O is tangent to the yellow circle at OQ is tangent to the yellow circle at point O. We defined the center of the yellow circle as point M. So MO must be the radius of the yellow circle because it starts from the center of the yellow circle and ends at point O. That point is point on the yellow circle itself. So MO is defined as the radius of the yellow circle, and for the same reason we can say that also MP is the radius of the yellow circle, and according to rule number 1, so rule number 1 states that if two circles touch each other either internally or externally, then their point of contact lies on the straight line joining their centers. I will explain the meaning of rule number 1 again. If two circles touch each other, the yellow circle touches the semicircle at point P, then their point of contact, that is to say point P, lies on the straight line joining their centers. The point of contact P lies on straight line. Which straight line? The straight line that joins the centers together. That is to say, PMO is a straight line because point P lies on the same straight line as MO. Because of the fact that point P lies on the same straight line as MO, PMO is a straight line, one straight line. Okay, so again, the point of contact, point P, lies on the straight line that joins the centers together, and the straight line that joins the centers together is MO, and point P lies on the same straight line. That is to say, PMO is a straight line. Okay? Actually, the meaning of rule number 1 is that if you draw a line between points P, M, O, you will get a straight line. That is the real meaning of this rule. That if from point P you will draw a line through P, M and O, then you will get a straight line. That is exactly the meaning of rule number 1. That the line segment that joins the two centers together, that is to say line segment MO creates with point P one straight line. That is to say, PMO is one straight line, or in other words, PO is a straight line. Okay, and for that reason also PO equals to 2 times small r. PO is also the diameter of the yellow circle, and because of the fact that PO is a straight line, we can deduce that PO is also the radius of the semicircle. Why? Because OP starts from the center of the semicircle, that is to say from point O, and ends at point P, that is a point on the semicircle itself, and that is exactly the definition of a radius. Any radius starts from the center of the circle and ends at any point on the circle itself. For that reason, OP is the radius of the semicircle, and we defined capital R as the radius of the semicircle, and also small r is the radius of the yellow circle. But we know that OP equals to 2 times the small r, and also OP equals to capital R. Okay? We found out that OP equals to the radius of the semicircle from one side. But we also found out that OP equals to the diameter of the yellow circle, or OP equals to 2 times small r. From that we can deduce that the radius of the semicircle equals 2 times the radius of the small circle, of the yellow circle. Okay, so that is equation number 1, that capital R equals to 2 times small r. And so we arrived to the conclusion that OP equals to capital R, but for the same reason we can say that OQ is also the capital R is also the radius of the semicircle, because of the fact that it starts from point O, that is the center of the semicircle, and ends at point Q, that is a point on the semicircle itself. For that reason, OQ is also the radius of the semicircle. We marked it as R. So we have OP, that is the radius of the semicircle, and also we have OQ, that is the radius of the semicircle. And also, according to rule number 2, in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have a radius and we called it R, and the tangent to that radius we called it T, then they are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, so we can implement, okay, again, in any circle, a radius and the tangent to that radius are perpendicular to each other. So we can implement this rule in our circles, because in our circles we have radius, MO is the radius of the yellow circle, and we have tangent QO to that radius. According to rule number 2, they are perpendicular to each other. That is to say, angle POQ equals to 90 degrees, because the radius is perpendicular to the tangent. The radius MO that is perpendicular to OQ. For that reason, this angle is 90 degrees, or angle POQ equals to 90 degrees. So in total, we have here a right triangle, because POQ is a right triangle because of the fact that angle POQ equals to 90 degrees. For that reason, triangle POQ is a right triangle. So we draw again triangle POQ, angle side OP of the right triangle POQ equals to capital R, side OQ of triangle, the right triangle OPQ equals to R, and the hypotenuse of triangle right triangle OPQ equals to 7 times root 2. So we can implement here the Pythagorean theorem in order to find out the value of capital R. And the Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Or in other words, AC squared equals to AB squared plus BC squared. Okay, so we can implement it in our right triangle, and we actually can say that in our right triangle OPQ, PQ squared equals to PO squared plus OQ squared. Okay, this is the implementation of the Pythagorean theorem on our right triangle, and the Pythagorean theorem applies only on right triangles. So PQ squared equals to OQ squared plus PO squared, but we know that OQ equals to R, OP equals to R, and PQ equals to 7 times root 2. So we can say that R squared plus R squared equals to 7 root 2 squared. Okay? R squared plus R squared equals to 7 root 2 squared. Okay? And it is very simple to solve the equation. We got to the equality that capital R equals to 7 units, but we have equation 1 that states that capital R equals to 2 times small r. So we can substitute capital R in the first equation by 7, and we can make the equality that 7 equals to 2 times small r. We divided the equation by 2, and we got that small r, the radius of the yellow circle, equals to 3.5 units. And after we know the radius of the yellow circle, it is very simple to find out the area of the yellow circle, because the area equals to pi times r squared, and we have already know that r equals to 3.5 units. So we can substitute r in the third formula by 3.5. We square it and we multiply it by pi, and we got to the final answer that the area of the yellow circle equals to 30.48 units. So the area of the yellow circle equals to 38.48 units. Okay, thank you very much.